In this demonstration, we're going to go through the numbering systems a little bit more in the form of a demonstration, which is sometimes a bit easier to explain. So remember, we've got three numbering systems. We've got the binary numbering system, which is a base of 2. Okay, we have the decimal numbering system, which is a base of 10. And then we have the hexadecimal, which is a base of 16. Okay. I want to draw that out. I know that base number probably doesn't mean much to us, but it's very, very key because these numbering systems are all the same. They just have a different base number. What does it mean by a base number? Well, in binary, base 2, okay, that means there are only 2 possible values. The values 0 or 1. In decimal, base 10, it means there are 10 possible values, 0 through 9. And in hexadecimal, it's 16 possible values. It's 0 through 15. Okay, so same deal again here. It's just a different base number, and you could actually argue that that binary is a little bit simpler because there's only 2 possible values. It's either on or it's off. Let's start with binary, okay? And I'm gonna draw up. Well, actually, I'm just gonna type this out, and then I will explain what it is, okay? You should do this on the exam. They give you a little piece of paper. You should immediately start at 128 and start on the left and start dividing by 2. Again, I'll explain this. Okay? Each of these represents a bit, holder area. A bit value. Now, where do we come up with this? Well, we take the base number 2 and we start taking it to the power of something. Okay, so 1 again, and this is, you can't write this, but the very first number here is going to be the base number 2 to the power of 0. Okay, and anything to the power of 0 is always going to be 1. Okay, the second number is 2 to the first power. The third number is 2 to the second, or squared. The third is 2 to the third, or cubed. Okay, 2 to the fourth, 2 to the fifth, 2 to the sixth power, finally 2 to the seventh power. Okay, that's how you get that's how you get those numbers. Now, like I said, you could just kind of write it out and just deal with it. And you don't care about the exponents, but that's where they come from. Okay, so if you get a binary number that looks like this, and they ask you to convert it into decimal, all you have to do is place that number here under the corresponding values. Okay, so 1, 0, 0, 1, 1, 0. You see, I'm just placing the values there, and I know the spacing's a little weird, but just trying to get it to where it somewhat matches. Okay, so you're just placing the binary value underneath the decimal, and then essentially, if it's a 1, that value is on. Okay, now the value itself is not 1. 1 is just yes, 0 is no. So that means we're going to count this 128. So I would basically just go, okay, well, and you can say plus 0, plus 0. I'm just going to not count. So if it's 0, I'm not going to count it. If it's a 1, I'm going to count it. Okay, and then the last one would be a 1. So that's how we would convert, and we would then just simply add up those numbers. What is that? 140, that's 153. Okay, so this binary number equals 153 in decimal. And we know that because we take the number and we place it under here. If it's a 1, you count the corresponding value. If it's a 0, you do not count the corresponding value. A couple of key things here. Let's get rid of that number and let's switch the number to something else. Let's say you get presented with a number like that, 1101. Okay, very, very important here. If the binary number is not a full 8 bits, you have to add preceding zeros. You can't add zeros at the end. It'll completely mess it up, okay? You have to add preceding zeros. Now, you don't have to, but they're there. And so you have to know that, in this case, the 128, the 64, the 32, the 16, the first 4 bits are all going to be 0. You're not going to count any of those. Okay, so automatically my number is, we're already way over here. 1101. Okay, that's 8 plus 4 plus 1, that's 13. Well, that's completely different than if I were to throw the zeros at the end and go like that, right? I mean, it's going to be a totally different value. That's going to be like 100 and, what do we get, 208. Okay, so that's the key. If it is not a full 8 bits, you must add preceding zeros. All right, we don't deal with numbers that are larger than 8 bits here. So you will be asked potentially to convert these numbers, but it's simply taking the binary number and throwing it underneath this line, whatever we want to call it, and then just adding the values that have a 1 configured. Don't add the values that have a 0. Now, what if they give you a decimal number? What if they say, well, let's see, 232. What is 232 in decimal? Well, this way we go kind of backwards. We go to the opposite way. And so I'm going to basically take and just ask myself a question. I will start from the left, and I'm always asking myself, okay, can I subtract 128 from 232 and still have a positive number? And the answer is yes. Okay, so I'm going to count that. So I'm going to count that value, and then I'm going to go over, and then I'm going to take 232 and subtract 128 from it to see what I'm left with. Okay, and in this case, what am I left with here? 104. Yeah. Okay, so then I say the same thing. Can I take 64 out of 104? Yes, I can. And that's going to leave me with what? 40. Can I take 32 out of 40? Yes, I can. There we go. Okay, so I'm still counting ones. Now I'm at a point where my number's down to 8. Okay, so that actually makes it kind of easy because that's one of these values. So I just know, okay, well, it's going to be a 0 for the 16. It's going to be a 1 for the 8. Now we're at 0. And so we just go like that. Okay, and the beauty of this is it's a built-in automatic system to where you can check yourself. Okay, there should be no issue of being able to check yourself. You've already got the number. Okay, now just add these values up. Okay, let's see. 128 plus 64, that's 192. Plus 32, that's 224. Plus 8, that's 232. Okay, there you go. That is the correct one. Now, just so you know, from a learning perspective, the Windows calculator in Windows 10 does support this type of mode. So you can check yourself if you would like. You can go in here. You got to be in programmer mode. But you can go in 232 and you can see the binary equivalent of it. Okay. Now, as you might imagine, you are not going to have this type of calculator on the exam, so you need to know how to convert it yourself. Okay. The base or the decimal and the hexadecimal numbering systems, they really are the same. We just don't think of them that way. Again, the base number is a little different. Hex is the weird one because hex is going to get us into the territory of letters. Okay. Because here's the problem. None of us actually operate like this. But if I were to take base 10 and I'd say, okay, what's 10 to the 0 power? Well, that's 1. What's 10 to the first? That's 10. What's 10 squared? That's 100. And what's 10 cubed? That's 1,000. Okay. We don't think of it that way. But when we say a number like 232, what we had, well, we kind of know just because we use this numbering system all the time. That's 2 hundreds, 3 tens, and 2 ones. Okay, they each have a place. So every one of these places, notice the numbers are just different because the base number is different. Every one of these places is going to have a possible value of 0 to 9. Okay, so we probably don't think about that because we're just so used to the decimal numbering system, but that is actually working the same way. The base number is just different. When we get to hex, we have a bit of a problem, okay, because the numbers, I mean, first of all, the numbers are much bigger, but it's not only that. So we would start at 1, and then we would have 16, and then we would have 256, and then I think the next one is 4096. Okay, so that's 16 to the 0, 16 to the first, 16 squared, 16 cubed. Well, the issue is that we've got values from 0 to 15. So you can't, if you have the value of 1, 5, you can't just assume it's 1, 16, and 5 ones. What if it's 15 ones? You know what I'm saying? So you have to go to letters. Hexadecimal will go to letters. As soon as you get to double digits, 10, it's going to be A. Okay, so in the hexadecimal numbering system, 10 is equal to A, 11 is equal to B, 12 is equal to C, 13 equals to, I'm hitting the different ones there, D, 14E, and 15F. Okay, so you will see letters. Don't let it throw you. That's just so that we can maintain this one character, or one place basically. So you would see something like 5F. Okay, that means 5 times 16 plus 1 times 15, because the F represents the full 15 characters. So just keep that in mind. The other thing about hex is you can take one digit and you can convert one hex digit converts into 4 digits of binary, because you think about it, it's 0 to 15. Those are the possible values, and that's the possible values in 4 bits. So you can, if you need to convert hexadecimal to binary, just go 1 bit at a time, right? Let's say this is 5F. So 5F, I'm going to go 1 bit at a time. I'll start with the first. What's 5? Well, 5 is 0 in the 8, 1 in the 4. All right, 1 in the 4, 0 in the 2, and then what? Okay. So the 4 and the 1 bit, that would equal 5. And then what is F? F is 15. And you can, we can go and check that. 5F in hexadecimal is going to be equivalent to that. So let's see here. I don't know that we can actually, we got to click on hex. There we go. 5F. Oh, it didn't do 5, sorry. 5F. Okay. 0, 1, 0, 1, 1, 1, 1, 1. All right, that's hex. And basically, again, all you're doing is you're treating each individual hex digit as a 4-bit binary number, and that'll allow you to do that conversion. Now, I know that's a lot. I know this isn't stuff that we think about. You might even think it's kind of silly. I might even agree with you. Because on a normal, regular basis as an IT professional, we don't really need to know binary. We don't need to do things in hex. But this is stuff that's been on the exam and will continue to be. Not a lot, so just you got to try to get the conversion down. Again, use the calculator to check your work, but make sure you know how to get there, because this should be an easy answer or two for you. There are occasions when we deal with IP addresses that we do see binary and possibly even hex with IPv6, but it's rare, but it's not completely out of the realm of possibility. So that's going to complete this demonstration where we take a look at the different numbering systems that we can use in a computer.